Hello class! Today I would like you to experience a variety of different molar conversions, and that means that we're going to convert a lot of different units in and out of moles. And recall that the reason why we use moles in chemistry is because our atoms are so small that we need a large number of them, or at least a mole of them, in order to make measurements and to observe them macroscopically in order to do these types of calculations. We have referenced some of these calculations before, and so the main goal that I have planned for you today is to do some examples to work through several calculations with your peers in all these different types of conversions. So let's go ahead and give some examples just so you have an idea, so you can brush off the cobwebs of the types of calculations we'll be doing. So first, we have something called a mole map, and in that mole map we can convert those moles into a variety of different units using different conversion factors, that dimensional analysis, that fact-factor method. The first unit that we've seen a little bit of is mass. So if I was to convert between mass and moles for the different units, then I would want to use my molar mass as the conversion factor between grams and moles. And this is similar to example problem number 1 that we see on your practice worksheet. So how many moles are in 9.8 grams of calcium? In this situation, my fact is the 9.8 grams of calcium. My factor, because I'm in grams and I want to know moles, then I'm going to go through the molar mass of calcium. Calcium on the periodic table is an element. So first, let me set up my units. I have grams on top. I want grams to cancel. So I put grams on the bottom so that they cancel. And then moles are the units that I want to get to. So that's the unit on top. And in this case, I would want to use the molar mass of calcium. That's on the periodic table listed as 40.078. And so that would be 1 mole over 40.078 grams. In this case, your number is always going to end up with your gram, and it's for every 1 mole. So when we calculate this out, 9.8 divided by 40.078 gives us 0.24 moles when we round this to significant figures. Yes, I went through that calculation rather quickly. You've seen it a little bit before. I want you to see these different types of calculations and then have practice with them later on. So that's why I'm going through these quickly, so you have some time to work on them later. The main point I want to make is that when you're going between mass and moles, you're going to use that molar mass that you can calculate from the periodic table. Now, another possible unit that we could convert moles into could be particles. And this is kind of the counting aspect of this measurement. So recall that there's a mass measurement, there's a counting measurement, and there's a volume measurement. Like if we picture a bag of rice, we could measure mass, volume, or count the little individual grains. And so with moles into particles, that's when I use Avogadro's number as my conversion factor. And recall that Avogadro's number is 6.02 times 10 to the 23rd items, and that is equal to 1 mole. Now, the term items in chemistry could mean a variety of things. So in some examples, it could ask about atoms of a particular element. So for example, I could ask about how many atoms of sodium are in this sample. It could also ask about molecules. So if I had a molecular compound, such as water, something that has those covalent bonds and those sharing of the electrons, then it would refer to molecules. For example, how many molecules of water are in this sample, or how many molecules of carbon dioxide are in this sample. The other type of substance that we've worked through a little bit is the ionic compounds. So your cations, your anions, your balancing of those charges, your metals and your nonmetals. So in that case, the term we would actually use is called a formula unit. We don't call ionic substances molecules. You'll learn that a little bit more next year, but for right now, all I want you to know is that these are the different possible units that we could have. And if we're in any of these units and I'm trying to convert to moles, then I'm going to use Avogadro's number as that conversion factor. And this shows up a little bit in number 11 of that worksheet. So, how many formula units are in 5.5 moles of sodium bicarbonate? We're already in moles here, and I'm trying to find formula units, which goes here, so I don't have to go through molar mass at all. I don't need to go this direction to get into mass. The only thing I have to worry about in this conversion is that I'm starting in moles, I'm going to go through Avogadro's number, and end up in particles. So in this case, my fact would be that 5.5 moles that were given. I would want to set up my units to cancel, so moles on the bottom so that it's diagonal. And then I want to go into formula units on top because that's what my question is asking about. And my relationship is that 1 mole, so 1 mole, is equal to 6.02 times 10 to the 23rd items, or 6.02 times 10 to the 23rd formula units. So that's the number I'm going to put on top, 6.02 times 10 to the 23rd formula unit. Recall that when you plug this into your calculator, you're going to want to use that scientific notation. So I'm going to plug this in as 5.5 times 6.02 E23. And when I do that in my calculator, I end up with a number of 3.3 times 10 to the 24th formula units. So we're still using that dimensional analysis process that we've seen before. We're still canceling units. We're still plugging it into our calculator like we've seen. The only difference is that now I'm using Avogadro's number as my conversion factor. And in my first example, I used molar mass. So depending on the units you want to get to, you have a different conversion factor. Now, the third measurement that I'm introducing for the first time for you guys today right now is that volume aspect. So particularly we're going to care about volume of a gas, and this is considered at STP, which stands for standard temperature and pressure. And standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. So this is just the temperature that it's at and the pressure of our gas. And so if I'm trying to convert moles into volume of a gas, then the relationship I would use is 1 mole is equal to 22.4 liters of your gas. And so that might not make a lot of sense as to where that number comes from. It's a little harder to explain right now in the video, especially when I'm trying to keep this video short. So for right now, we're just going to use that 22.4, and then we'll dive a little bit more in depth as to where that comes from when I'm back returned to class. Number 14 is one of the examples that you're given where you're using this conversion factor. So determine the volume in liters occupied by 0.030 moles of gas at STP. So again, we're starting in moles, trying to end up in volume. We're going to use that as our conversion factor. So our fact, 0.030 moles. I want to cancel my units, so moles is on the bottom. I want the volume of my gas in liters to be on top, and I'm doing that so that those are diagonal from each other. And then the numbers that I plug in here is that 1 mole, so there's my 1 mole, is equal to 22.4 liters. So I'm going to put the 22.4 on top with the liters. So in this case, I'm multiplying 0.030 times 22.4. I get an answer of 0.67 liters. Now, some of the other examples that you'll see are going to be multi-step calculations. So in these units, I was converting between, or in these examples, I was converting between those two units, or I was converting between those two units, or I was converting between those two units. You can also have something where you're starting in mass and trying to end up in atoms. And so in that case, in order to go from to go from mass into atoms, we have to go through molar mass first to get to moles, and then we go through Avogadro's number to get to atoms. We could also start in atoms and go to volume, in which case we're going through that mole conversion. Or we could start in volume and end up in grams. So you can chain these together in a multiple step calculation in order to go from one unit into a different unit. And that's what's happening in number 18 on that worksheet. So how many oxygen molecules are in 3.36 liters of oxygen gas at STP? So some things to point out, it's asking for the molecules, which is going to be way down here in this bottom right corner, molecules. But we're starting with our fact of 3.36 liters. So I'm starting up here in volume of a gas. I'm ending down here in molecules. Let me zoom out a little bit and see if that helps. Okay, so I'm going to do that same thing where I set up my fact and factors. So my 3.36 liters is my fact. The only direction I can go is into moles, and so I'm going to use that 22.4 liters to 1 mole in order to convert out of liters. So liters on the bottom, moles on top. That was 22.4 liters for every 1 mole. I'm not done yet though, because I wanted molecules, and this only gets me to a unit of moles. So if I'm in moles and I want to go to molecules, then I use another conversion, and that would be Avogadro's number. So 1 mole is equal to 6.02 to the 23rd. So I'm going to set up my next factor, mole on the bottom, and then molecules on top. And I'm setting it up that way so that moles cancel. And my conversion factor is that 1 mole is equal to 6.02 times 10 to the 23rd molecules. So if I plug this into my calculator, then I'm going to do 3.36 times 1 times 6.02 times 10 to the 23rd. Again, use that scientific notation button to put that 23rd into the calculator. And then all of that divided by 22.4. You should get an answer of 9.03 times 10 to the 22nd. And be sure to put in your unit. So this is molecules. Same process that we've seen before in dimensional analysis. The only difference is that now and in that same process, we're still trying to cancel our units. The only difference is now we have a variety of conversion factors we can use to go from one unit into another. I hope that was helpful, and now I would like you to spend some time just practicing those different examples. Good luck!